Here we have a 40 loop coil 15 centimeters across with a 72 millitesla field going through it, and we're going to turn off the magnetic field in 60 milliseconds, which is going to induce an EMF and a current in this coil, which is then connected to a transformer with 600 loops in the primary, 1400 loops in the secondary, and the secondary is then attached to a 20 ohm resistor. We're going to find out what the current in the resistor is, as well as draw the induced current in the initial coil to begin with. So let's just start with the electromagnetic induction over there. Now, first of all, I'm going to find out how much flux I actually have going through the coil. So that's BA cos theta. Cos theta is equal to 1. It's all maximized. So if I multiply that to find my flux, I've got 0.00127 Webers of flux going through my coil. Now, when I induce the EMF, induced EMF is negative n delta phi b divided by delta t, it's just going to go down to 0. So my change in flux is going to be equal to this right here, because it's going to go from 0.00127 down to 0. So if I use that in here, and I use a n value of 40, because I got 40 loops, and my delta t is the 60 milliseconds, I can find that I am going to induce an EMF of about 0.848 volts, and this would be equal to my primary voltage. Now that I have my primary voltage, I can use that to find out my secondary voltage inside my transformer. Now, using my basic transformer expression, N1 divided by N2 is equal to V1 divided by V2. Since my loops is getting higher, my voltage is going to get higher. And I have my V1, I've got N1, N2. V2 is the only thing I don't have. And if I solve for V2, I can find out that my secondary voltage is about 2.0 volts, which is how much voltage would be inside of that resistor, since it's the only thing on the circuit. Now that I've got that, I can use basic Ohm's law to find out how much current would be in that resistor. So I've got 2 volts, I've got 20 ohms, divide that 2 out, and I've got 0.10 amps of current running through that resistor. Now that I've taken care of that, I'm going to try and find out what my induced current was in the loop over here. Now, for my induced current, I started with a magnetic field made of dots, and since I am turning the field off, the coil is going to lose dots. So since the coil is going to lose dots, so our magnetic field is going to lose dots. So in order to compensate, the coil is going to make dots. Okay, so that's based on Lenz's law and that type of stuff, where it tries to undo what was done. So my induced magnetic field would be dots. Well, if my induced magnetic field is going to be dots, in order for that to occur, the current, according to right-hand rule number 1, would have to travel in this direction. So that would be my induced current going in a counterclockwise direction in order to recreate the dots of magnetic field that the coil lost when the field was turned off.